What's up guys, it's Brad from LightArchitect. Today I have a very exciting video. I'm going to be showing you how you can create some Meteor effects similar to that visual effects Meteor breakdown that we've released last week on our channel. This effect is surprisingly simple in concept and you can do a lot of different things to it in order to dial in a little bit more custom result depending on the look of the simulation that you're going for. In this video I'm going to be using the KHAOS add-on and Fire shader, but I will share some tips on the concepts behind creating this effect if you don't have that add-on as well that you can apply in your own creative process. Anyways guys, let's get started. Here we are inside of Blender. As usual, the first thing we're going to do is just delete everything in our scene here. And for this Meteor effect, essentially we just need two main elements. There are some other things and adjustments we're going to make in order to make it look a bit better and a little bit more customizable, but the two main elements you're going to need is a smoke domain and a flow object. And this is the main step that I'll be using the KHAOS add-on for. However, if you don't have the KHAOS add-on and you want to create these two things, I'll show you how to do it real quick. Let's go ahead and press Shift A. I'll go ahead and add a cube, scale it up here, and I'm going to use this as our domain. So I'll go to our physics properties tab here, add a fluid property here, change the type to domain. And now we have a domain cube that we can simulate within, and we can change our resolution divisions and all of our different settings here according to the style of simulation that you want, which I'll go over here later in this video. If you're not using KHAOS's smoke domain, you will need to change a few of the settings here. The main one being for your cache, you're going to want to change this to modular, and then you can bake your data and then choose where you want to save that data. But anyways, I'm going to be using the KHAOS smoke domain. So if you have KHAOS, forget about this step. The second element that we're going to need is a flow object. So again, if you don't have KHAOS, I'll go ahead and press Shift A and create one. We can use any of these basic meshes here. I'm just going to use an icosphere. And what we can do to make this a flow object and emit smoke and fire, we can just again go to our physics properties tab, click on the fluid option, change the type to flow, and change the flow type to either fire and smoke or fire. I'm going to use fire for this example. And then finally we want to change the flow behavior to inflow. And now you have created your Meteor as well as your domain cube. But anyways, if you do have KHAOS, go ahead and skip past these steps and let's start using KHAOS. So go ahead and open up our side window here, navigate to the KHAOS tab. We're going to scroll down here to the KHAOS extras. And now we want to use the smoke plume operator here to build both our Meteor and our smoke domain cube with the KHAOS Fire shader all in one step. So I'll go ahead and click on the smoke plume button here, and when you click on that, you're going to get a few different options to adjust your smoke plume. And essentially what this operator does is it's going to pulse the fuel in your smoke flow object over time to give it a little bit more organic result. So you can choose the highest fuel rate that your flow object is going to emit, your lowest fuel rate, and then the fuel pulse timing, essentially the number of frames in between these two values over the course of your timeline. So I'm going to change the highest fuel rate to something like 2. So we have a little bit more fire, a little bit more violent burning effect. And then I'm going to change the lowest fuel rate to 1. And I think for the pulse timing, probably do something a little bit smaller. So maybe half a second. Every half a second, it's going to pulse from 2 to 1. So I'll maybe do something like 12 frames. And finally, now I'll click on the smoke plume button once more. And now as you can see here, we have a smoke plume which we're going to use as our Meteor, as well as our smoke domain cube, which contains our KHAOS Fire shader and a lot of the domain settings that we're going to use here. All right, so now that we have our two main elements, let's set up our scene to bake the simulation. So I'll go ahead and bring up our smoke domain here, and we just want to make sure that the smoke domain is big enough to surround our entire simulation. So I'll go ahead and just scale this up a little bit on the Z-axis and also on the Y-axis. And I'm going to actually animate our Meteor kind of coming down here to the left. So actually I'll bring this up a little bit, something like this. And bring this down a little bit. We just want the domain cube big enough to contain our simulation, but no smaller than that. So now we're going to animate our comet. Going to start with our Meteor just out of the domain cube on frame 0. I'll press I, add a location, rotation, and scale keyframe. And then for the course of the simulation, I think maybe we'll do until frame 150 maybe. So I'll just grab our smoke plume emitter, drag it down here, just all the way out of our domain cube here. And I'm also going to rotate it a bit so that it's rotating as it goes through our domain cube. I'll press I again, add another location, rotation, and scale keyframe. And now as you can see here, we have a meteor going through our smoke domain. And as you can see here, it kind of starts speeding up and then slows down at the end of our animation. So what we want to do is actually make the extrapolation mode for this animation linear. So to do that, I'll select our smoke plume emitter once more, go to our graph editor, and then go to channel, extrapolation mode, linear extrapolation. And now as you can see here, it's a constant speed as it goes through our smoke domain here. And it's not moving very fast, so I'm actually going to increase the speed of our meteor just by dragging the final keyframe here, maybe to frame, we'll try maybe frame 80, see how that looks. That's looking much better. And also the rotation is looking a little bit weird here. So I'm just gonna kind of give it a lot more rotation there and see if that helps. And that might be a little bit too much. Let's try it one more time. Delete that. I'll try this once more here. Just give it a little bit different rotation this time. Try this out. And that's looking a little bit more organic in my opinion. And I'm also just going to drag this keyframe over a little bit more. We actually want it to go quite a bit faster. Yeah, that's looking a little bit better. And I'll also drag our keyframes over here in the timeline so it just starts a little bit further up. And then I'm just going to make our domain cube surround it for a little bit longer. So I'll increase it on the x-axis as well as the y-axis. Make sure it's completely around where our simulation is going to be. All right, cool. So we have one meteor. Feel free to duplicate this process and add more meteors if you like. So maybe what I'll do is just select this main meteor, press Shift D, duplicate it, and then add some different keyframes. Maybe make it smaller at the end here. So these are like trailing meteors. So I'll add a keyframe here for this one. And then, you know, same thing over here. Just to give some variation. So we have several different meteors in our scene. And now we have 2 meteors. So feel free to repeat this process for as many meteors and little pieces of meteor that you want. All of these will be flow objects, so you'll be able to simulate them all like this. So I'll just repeat that process and then we'll get back to the video. All right guys, so now I have a few different meteors going through our domain cube here, and just to make sure our animation is looking like the speed that we want it to be, what I'm going to do is I'm just going to use our viewport render animation option here so we can play it back in real time. I'm going to maybe do this simulation from frame 0 to 100, so about 4 seconds, maybe frame 110, maybe 120. Since the simulation starts a little bit late. So yeah, go to frame 120, maybe 130. So maybe 130 here. And now what I'll do, first I'm going to actually save our project here. Call it Meteor Tutorial. Save it just in case we lose something. And now what I'm going to do is I'll go to View, Viewport, Render Animation. And now Blender is going to go through all of our frames in preview mode just so we can play them back in real time and get an idea of the speed of our meteors before we simulate them. All right, so I'll go ahead and close that here. Now to play it back, we'll just go to Render and View Animation. And yeah, I think this is going to look pretty good. If anything, it could be a little bit faster. But yeah, maybe a little bit faster. So what we can do, we can select all of these and just grab the last keyframe and move it over maybe like to frame 60. So it's really quick. All right, yeah, that's pretty quick. All right, so before we bake our domain cube, we want to add some turbulence fields to kind of break up the smoke and fire that these meteors are going to emit. And how we utilize these turbulence fields to kind of break up the smoke and fire is sort of up to you depending on the style of simulation that you want. But what I like to do is I first like to add a larger scale turbulence field to add large scale detail to the smoke. And then I also add another one for smaller scale detail to break up the smoke and fire. So what I'm going to do is I'll go ahead and press Shift A. I'll add a force field turbulence. And that's just gonna add a little turbulence field to our scene here. And what I want to do is I want to make the strength maybe something like 5. So not too much, but noticeable enough to break up the smoke over time. And then I want to make the size of this large scale turbulence field about 2. And then I'll leave that one as is. One thing you can do if you want to break up the smoke in a little bit more organic way is you can actually animate the movement of these turbulence fields so that the noise pattern that they're creating on the smoke actually changes over time. So what I'll do, just grab this guy, put it down here. At frame 1, I'll press I, add a location, rotation, and scale keyframe. And then I'll go to frame 130, bring it up here. Again, add another location, rotation, scale keyframe, and now we have some movement on our turbulence field, and that just might break up our smoke a little bit more organically. So just a nice little trick. You don't have to do that, but I found that it gives a little bit of an interesting result. So now we want to add our smaller scale detail turbulence. So what I'll do is I'll just press Shift D, I'll duplicate this turbulence field and place it off to the side here. And now what I want to do is I'll keep the strength the same at 5, but I will decrease the size of this turbulence to something like maybe 0.1. That's just going to make those smaller scale bubbles in our smoke and fire, depending on our domain resolution, of course. All right, so now we have our turbulence field, our smoke domain, as well as our animated meteors. And you can relabel these if you like, but I'm going to leave them as is. And now what we want to do is we want to adjust a few of our smoke domain settings and then bake our initial explosion base mesh. So I'll go ahead and select our smoke domain here. And one thing I like to do when creating any kind of smoke and fire simulation in Mantaflow is in the experimentation process, I keep the resolution divisions low to start out, and then I slowly increase the resolution divisions until I get the shape of smoke that I like. Essentially how this works, the more resolution divisions you have in your smoke domain cube, the more voxels, or essentially little areas of detail in your simulation there's going to be. A lot of the time for smaller scale simulations, I will decrease the resolution divisions quite a bit, and then I will add more noise and detail with the noise upres factor here. And then for larger scale simulations where we want a lot more initial noise and movement in the simulation, I will actually increase the resolution divisions quite a bit, and then you'll have to use less noise upres to get the resolution that you desire. So I hope that makes sense. You can still get really detailed simulations if the resolution divisions are low, but you'll just have to upres the initial mesh. So resolution divisions is one of the main things you have to control in order to get the desired shape of your smoke initially, and then depending on the shape and how much detail is in it, you need to upres it according to the shot that you have. So anyways, I'm going to just do a test bake with, I think maybe I'll do something like 128 resolution divisions at first. And for this test bake, I'm also going to enable adaptive domain. For our final bake, we will turn that off just because sometimes we get glitches with this option. Going to leave dissolve on at a time of 300. And yeah, this is looking pretty good for the fire. One important thing that I've noticed is depending on how much fire you want in your meteors, you might want to decrease the reaction speed of your fire. So for example, the lower this number is, the more the fire is going to trail behind your meteor, which often gives you more detail in your smoke and fire simulation. For this specific example, I'm going to bring this down to maybe 0.06. And that's just going to give us a pretty slow burning fire so that the flames will trail off pretty far behind our meteors here. So that's a little trick there. Another thing, if you're not using KHAOS, you will want to increase your flame vorticity to 1 at least to get a little bit larger scale looking fire. But all of this looks pretty good so far. I'm going to choose in our cache tab here where we want to save our simulation data. So I'll end our simulation cache at 130. And then I'll choose this little folder here and create a folder for our simulation data. Go ahead and accept that. And now all your simulation data will be saved within this folder. And I do want to make our simulation resumable so we can pause it and restart it if we want to adjust things midway. So I'll go ahead and check that checkbox. And yeah, this should look pretty good. I'm also going to switch to our cycles rendering engine. I'm going to make the film transparent. I'm going to add an HDRI just so we have some lighting. Once we bake out our simulation, we can look at it better. And I'll also add an area light because when you bake your smoke simulation with the actual light, the smoke tends to look a little bit better, at least in preview mode, I mean. So just give it a little top light, make the strength like 1,000, maybe 2,000, something like that. And yeah, this should be pretty good. Gonna go back to our smoke domain here. And actually, since our smoke domain is pretty big, we scaled it up quite a bit. I'm actually going to bring up our resolution divisions back up to 196. Just because this domain is pretty big. The bigger you scale up your domain, the more you're going to need to add resolution divisions to compensate for that increase in size. But anyways, this looks pretty good. Go ahead and save it once more, and I'll click on Bake Data and give your computer some time to simulate your original explosion base mesh. All right, guys, we are back and we have created our initial test bake for our meteors, and it's looking pretty cool here. As you can see, if we go a little bit further in the simulation, we're getting some nice large scale detail from our turbulence fields, as well as some small scale detail as well. Obviously not super high resolution simulation yet. If we render this out, it would have to be a very distant shot to not notice the lack of resolution. But for an initial test bake, it's looking pretty cool. One thing I'm going to do is actually rebake this, but with a little bit higher resolution divisions, because I think, as you can see here, some of these meteors are pretty small. However, the resolution divisions is so low in comparison that the fire is being emitted much further out from the meteor itself. So maybe if we increase the resolution divisions to something like 256, our meteors are going to carve up the smoke and fire a little bit more effectively. But this is not a bad result. We could bake this out with some high resolution noise and get a pretty clean looking result with a little bit of shading. So pretty nice result. As you can see here, because our reaction speed for our fire is so low, we're actually getting that nice trailing flame effect, really hot flame here, and then it's lasting all the way up to right here, at least from our preview. So that's going to help us with our shading, because we can actually shade how much we want the fire to go up in the trails of smoke here. So pretty nice looking result. I'm going to rebake this with a little bit higher resolution divisions, and then we'll add that high resolution noise as well. So I'll go ahead and free the bake. I'll increase the resolution divisions for this to maybe 256. And finally, I'm actually going to deselect adaptive domain for this one, since I'm pretty sure this is going to work for our final bake, and it's not just going to be another test bake. Go ahead and deselect that. And yeah, this should be pretty good. Once again, I'll save our project. And finally, I'll click on Bake Data, and we'll give our computer some time to simulate, once again, our explosion base mesh. All right, guys, so we are back and we have baked our original simulation base mesh here, and it's looking pretty awesome with 256 grid resolution divisions. So I'm going to stick with this for our initial bake here, and now it's time to bake our high resolution noise on top of this. Now, depending on if you want to just use this for a distant shot, you may have enough resolution. And again, the number one thing that's going to change the general look and feel of your simulation is this resolution division. So if you're not happy with the result, experiment around with the resolution divisions here, make it a little bit bigger, make it a little bit smaller, and you'll kind of get the hang of the experimentation process. But this is looking pretty good, and as you can see here in rendered view, our KHAOS fire shader is giving us a pretty nice looking meteor style effect here. There are quite a few things we could do in the KHAOS fire shader to make it look quite a bit better. However, first we're going to bake that high resolution noise on top of our simulation. So go ahead and go to solid view here. I will save our project once more. Then we'll scroll down here in our smoke domain settings, check the noise checkbox, and now we need to decide how much we want to up-res our simulation by. So depending on how detailed you want your simulation to be, you may need to up-res this by more or less. Other than the up-res factor and how much resolution you want to add to your smoke, the other thing that you may want to change is the scale of your noise that you're adding. At its default, the scale is at 2 for the domain cube that comes with KHAOS. 2 should be pretty good, I think. I might just dial it back to maybe something like 1. So it's a little bit smaller scale detail on the simulation, but this should be pretty good. And I'll make a video on the specifics of noise and turbulence and everything in the future, because that's kind of a complex topic by itself. But essentially this, as you can see here, if we hover over the scale, the higher the value of the scale, the larger the vortices of the noise that's going to be added to your smoke. So it's going to cut up the smoke in larger chunks the higher you set this value. So if you want small scale detail, bring it down. If you want large scale detail, bring it up. 1 should be pretty good. It's kind of in between. And I'm going to go ahead and click on bake noise with an up-res factor of 2. And once again, we'll give our computer some time to bake that noise on top of our original simulation base mesh. All right, guys, so we are back and we have baked our high resolution noise on top of our simulation base mesh, and it's looking pretty cool here. As you can see, If you zoom in pretty close, there's some high resolution wavelet noise baked on top of our initial simulation. So this is just a nice way you can add some detail on top of everything. So feel free to play around with this step in order to get a different style of result. Playing around with like the scale, the strength of everything, all in the noise settings here. But anyways, now it's time to finish off our Meteor with shading our simulation utilizing the KHAOS Fire shader. And then finally, we're going to add some sparks to our simulation in order to enhance the final result and then composite everything together effectively. So let's get started. I'll go ahead and go to the shading tab here. And as you can see here, our KHAOS Fire shader is ready for us. And if you don't have the KHAOS Fire shader, you can use a principled volume shader. So I'll go ahead and show you guys how to do that as well. So go ahead and press Shift A, just go to shader and then use principled volume. And then you can create an output node here, material output, and then connect this to your volume. And then I recommend playing around with the density value, the color value, and then the black body intensity here to increase your flame brightness. Anyways, I'll go ahead and delete that. We're going to be using the KHAOS Fire shader in our example. And right off the bat, if I just go to rendered view really quick, you'll see that we have a somewhat interesting result here. However, I do think we can clean it up a bit and even out the fire going through our meteors here. It's a little bit too bright here in my opinion. Even if we add some glow and glare, I think this is going to be a little bit too hot. So what I like to do is actually first play around with our color ramp here. So I'm going to drag the right orange point over here a little bit to make it a bit brighter. And then I'm going to add a new point here on our color ramp. And I'm going to make this one black. And what we can do here is actually drag this one over to darken down the bright spots of our simulation. So now as you can see here, it's a much more even flame through our meteors. And adding another black point here is just a nice way you can control the brightest part of the image without having to adjust the flame's brightness and contrast quite as much. And depending on your simulation, you'll have to make slightly different changes here. But I'm going to maybe first change our smoke color to something slightly darker, I think. And then I want to bring up the smoke density a bit as well to maybe something like maybe 6,000. So now it's quite a bit denser here in the areas that are burnt off a bit more. And I'm gonna bring down the flame's brightness a bit to maybe 4. And then also bring down the flame's contrast to maybe 5. And again, it's all kind of up to the style of simulation that you want, but just play around with these values a little bit. What I might do is drag our left black bar here over a little bit so that our flames aren't going quite up into the latter part of our simulation. Then I might also just bring our smoke color back up a little bit so it's not quite as dark. The smoke is looking pretty dense. I might bring down the smoke contrast a little bit to maybe 4. Maybe to bring down the smoke density to 5,000. Bring down the flame's brightness to 4. There we go, that's looking pretty nice. Burning off pretty nicely here. So depending on how much you want your flames to bleed into the smoke part of your simulation, you'll want to adjust these color ramp values here. And sometimes it helps to have other references as well, like some images, but this is the general concept here. So I think for the sake of this example, this is looking pretty good here. Of course, feel free to play around with different styles of results. You can also change the general color of your simulation as well. So if you want to make it a little more red, you could do that here. And we can also do that in the compositing process. So just kind of depends on what you like. Might go for like a red-orange look here, but I think this is going to look pretty nice once we add some glow and glare in the compositing process. So we'll go ahead and use this for now. Now what I'm going to do, I'll just go ahead and go back to solid mode here. Now it's time to actually add those sparks to our simulation. So I'll go back to layout mode here and I'll go ahead and select our Meteor flow object. Then we'll go to our particle system tab here. I'll add a new particle system. And actually before we play around with these particle systems, I'm going to go ahead and select our domain cube, go to the modifier tab and disable the real-time display modifier, just so we can work in real time a little bit quicker without the lag from our baked simulation. So this is what we're getting right now once we add that particle system to our main meteor here. And we want to take the gravity effect away from these particles. So I'm just going to go down here. I'm going to go to physics, and actually we're going to go to field weights. I'm going to turn off gravity, and let's see what that does for us. All right, so that's looking a little bit better here. Now what we want to do is change the lifetime of our particles to say something like, try something like maybe 10. See what this does for us. All right, that's not bad. Then I might add a little bit of velocity to our particles. So maybe something like, well, let's see here. It might be weird. Yeah, we don't want too much velocity because it's also going to be blasting out this way. So we want to just kind of experiment with it here. A normal velocity of 4 is not bad. Might be kind of interesting. Maybe try something like 5. And then let's go ahead and turn our smoke plume back on. So these particles are going to be a little bit too much in our simulation, so we want to give them a little bit more velocity so they're outside of our simulation. So to do that, we'll just turn this off once more, select it, go to the particle system tab, and let's see here. We could either increase the normal velocity to maybe 6, then give a little bit of randomize, maybe 2. There we go, it's not bad. And yeah, I think that should be a nice little particle system for adding some sparks to the simulation. So now I want to add these particle system settings to the other meteors in our scene. And actually what I can do in order to copy these particle settings to the other meteors is I can select all 3 of our other meteors here, and then select our main meteor, and then click on this little drop down menu, and then click on copy active to selected objects. And now as you can see here, we have that particle system on all of our meteors here. Now looking at this now, we do need to make a few adjustments here because the amount of sparks on the smaller meteors are a little bit too much. So there are several ways we could solve this. We could create our own particle system for each one of these meteors, or we could just kind of split the difference between the smaller meteor particle systems and the large one. So I'm going to do the latter, but feel free to adjust each particle system separately and play around that way. So I might just maybe decrease the randomize here a little bit to 1, and that's looking a little better. Maybe decrease the normal to 4. Yeah, I think that's looking pretty good. So now let's actually instance a spark on these particle systems so we can actually see what it's looking like in our render. So I'm just going to use an icosphere with an emission material on it for our spark particle. So I'll go ahead and press Shift A. I'll add a mesh icosphere, and we'll make it subdivisions pretty low here. We want it very low resolution since it's going to be so small. And this is going to be our spark particle. So go ahead and relabel it here. And we'll scale it down here, add a new material for it, go to the material tab, new, and we'll make it an emission material, and we'll make it kind of like a orange color. Maybe increase the strength to something like 10 so it's a little brighter. And yeah, that should be good. Put it off to the side of our scene here. Now I'll select our meteors once more, go to our particle system settings, and then for our render, we'll render it as an object, and then select our instance object to be our spark particle. And now as you can see here, when we play through our scene, we actually have these small icospheres with an emission material being emitted from our meteors. So a nice little effect here. Obviously we're going to need to add some motion blur and glare and grunge to them in post-processing, but this should work fairly nicely. I do want to decrease the scale of them a little bit and also add some scale randomness. So first I'll just increase the scale randomness to 1. So now there's a little bit more randomness in our spark particle. And I also want to select our spark particle here and change the material a bit. It's a little bit too saturated for my taste. So I'm just going to kind of dial it back a little bit, something like this. And of course we can adjust this in the composite as well. But yeah, that should be pretty good. And also, if you want to adjust the size of your particle, you can also just select your spark and scale it down this way as well. So now we have lots of little particles coming off of our meteors here. And I also might increase the amount of particles coming off of them. So I'll select our meteor, go to our particle properties, increase the number to say 4,000. And as you can see here, now we have lots of particles. And they're smaller particles, but it's just going to add a nice level of detail. So I'll go ahead and go to our cache here and bake out our particle system real quick. And of course, feel free to play around with your particle settings some more, but I think this should look pretty good. All right, so before we render this out, I want to add a material to our actual meteors. So what I'll do, since we're not really seeing the meteor too directly, since it's behind our simulation, I just want to make it a dark material. So I'll go to our material settings tab, create a new material, we'll call it Meteor. And I'll just make it just like a dark base color. like a rock color. You could add like a actual rock texture to these meteors, but since we're going to add so much glow and glare on top of everything, it's not really going to be seen that well. So I think this should work just fine, and then we'll copy that material to the rest of our meteors. All right, so this should look pretty good. I'll go ahead and turn our fluid simulation domain cube back on in viewport display mode. And I think this is going to look pretty cool here. So we have our particle systems, we have our fluid simulation, we have a basic HDRI and a top light added to our scene. And now it's time to set up a few view layers so that we can composite both our sparks and our simulation on top of each other a little bit more effectively. So I'm going to do this in a fairly simple way. However, I am going to export an emission pass of our smoke and fire so that we can add some glow to that layer specifically. So we're going to have two view layers in our composite. One of them will be for our simulation, which will include two passes, one beauty pass and an emission pass, and the second view layer will just contain our sparks. Before we adjust our view layers, I'll go ahead and add a camera to our scene. So I'll press Shift A, I'll add a camera, and we'll just put this off to the side here, and we'll view from our camera here. Pull back a little bit. I want to change the focal length here in our camera settings to maybe just a 32mm. That should be fine for a test render. And just kind of choose a cool angle, something like this. It's kind of interesting. All right, so this should be a pretty cool angle for our test render. Now let's separate our view layers. This first view layer, I'm going to rename this Meteor Simulation. This is for our smoke. So this one's just going to be our smoke domain here. So I'll just go ahead and organize our scene here. I'll select our smoke plume emitters here, all of them, press M, move them to a new collection. We'll call them sparks. And now we have those organized. Our turbulence fields will put in their own collection. Press M, new collection, turbulence. Then we have our camera. We'll just add that to our main scene collection. And then we'll move our smoke plume domain to our main scene collection as well. And our spark particles can go in our sparks collection. Whoops. And then our area light can just go in our scene collection here. All right, so now we have our scene a little bit more organized. I'm going to click on this drop-down menu here. We're going to enable all of our restriction toggles so we can enable holdout and indirect only options on each view layer. So now what we'll do, for this first meteor simulation view layer, we don't want any of our sparks to show up. So as you can see here, I'll go to rendered view. What we want to do is turn off our sparks. I'll enable this one as indirect only for this view layer. And now as you can see here, they disappear on this view layer. So now we just have on this view layer our simulation. So this should work pretty good. Now we want to create a new view layer. So I'll go ahead and go to solid view really quick and create a new view layer here. Click this, new view layer. And now what I'll do is I'll call this view layer sparks. And for this view layer, again, I'll go to rendered view so we can see what we're working with. And what I'll do is I'll turn our smoke plume domain into an indirect only option. And now we just have our sparks in this specific view layer. And I'm also just going to not render our meteors in this view layer at all. So for our meteors, just going to go to the particle settings here. For our render display, I'm going to deselect the show emitter option. And also for our viewport display. And we'll do the same thing for these. And now as you can see here, we're not actually seeing the meteor that's emitting the sparks, but just the sparks by themselves. And I do want to adjust the spark particle system before we do a test render, because looking at it, it's a little bit too uniform. So what I might do to solve this is actually reselect one of our meteors here, go to our particle system settings. We want to be careful here because we don't want to delete all bakes and have to rebake our simulation. So I'll just delete the bake for this main meteor particle system. And I want to increase the lifetime randomness all the way to 1, and then maybe also give it a little bit more randomness in general. So maybe the normal bring down to 3, and then the randomized will bring up to 2. Now we'll rebake this, see if this gives us a slightly different result. And I'll actually turn off our smoke domain viewport display in the meantime. And actually we want to leave the viewport display for our meteors on, so go ahead and turn those back on so we can actually see them in the viewport. I didn't anticipate any adjustments, but here we are. So leave those on in the viewport, but in the render we won't actually see them. All right, go ahead and select this one, delete the bake, rebake it, Let's see if that gives us a little bit. Yeah, it's giving us a little bit more variation. All right, so this one's looking a little better. We'll do the same for these. So I'll select our other meteors, delete the bake, rebake it. And since they're all on the same particle system settings, they'll all have those changes applied to them. So just deleting the bake, rebaking it. All right, so let's try these out. So go ahead and go back to our smoke plume domain, turn on our fluids, go to the rendered view, see what our sparks are looking like in this view layer. I think that's looking a little bit better here, but once we get into the compositing process, we'll know for sure. But yeah, this looks pretty good for our view layer. Now, before we do a test render, I do want to make a few more adjustments to each view layer. What we want to do is for our view layer properties, for the sparks view layer, we want to include just the combined pass here. And for our meteor simulation view layer, we want to include a combined as well as an emission pass here. So go ahead and select that, and now we can have the fire and flames isolated on a specific pass, so we can add some glow and glare to that specifically if we need to. All right, so this should be pretty good. Before we do a test render, I want to increase the volume bounces for our simulation for a little bit nicer result. So I'll go to our render properties tab here and adjust a few of our settings here. For our sampling, for render max samples, I'm just gonna make the max samples for our test render something like maybe 40. I'll turn off denoise for now. And for advanced, I'll select the seed stopwatch for some noise variation. And for light paths, this is key here. We wanna increase the volume bounces to at least 2 or 3. I'm gonna go with 4. And what that's going to do is it's going to allow the light to bounce in the volumetric simulation, which is going to provide a much more realistic result. And yeah, that should be pretty good. I also want to enable motion blur specifically for our sparks. Just go ahead and select that. And for our shutter, I might try something like 0.4 for now. So essentially, the higher this is, the more motion blur you're going to get. So this looks pretty good. I'll go to our output properties tab here. 1920 by 1080p resolution looks good, 100%. For our output, go ahead and choose a folder here to output our render in. Meteor tutorial render. And do this here. All right, so we have a place here. And for test renders, you can leave it in PNG. However, I'm going to render this out as a multi-layer OpenEXR. So go ahead and select that. And yeah, that should be pretty good. We'll go ahead and save our project once more, and we'll just go to render and render image, and we'll wait for Blender to render out our simulation and get into the compositing process. All right, guys, so this is our test render, and it's looking pretty cool here. This is just our first view layer, our meteor simulation, and then on our second view layer, we have our sparks right here. So now let's get into the compositing process, and I'll show you guys how we can composite these two layers together in order to get a nice looking final result. So let's get started. We'll go ahead and close our render view here, and we'll go to the compositing tab, and I'll click on the use nodes option. I'll go ahead and press Shift A. We'll add a output viewer node, and we'll connect our image to our viewer output. I'll press V a few times to get a wider view here, and now let's start comping everything together. So the first thing I'm going to do is duplicate our render layers here and overlay our sparks onto our meteor simulation. So I'll go ahead and press Shift D, duplicate this, and then I want to choose the sparks view layer, and I'll press Shift A again, add a color alpha over. Add this right here, and then I'll connect our sparks image to this alpha over node. And now, as you can see here, we have our sparks over top of our meteor simulation. However, I actually want our sparks to be under our simulation. So I'll go ahead and just flip these real quick. And there are some more complex ways we could composite this together. We could use like a Z-pass to blend them into the 3D aspect of the meteor. This is looking pretty good for now. I might add some glow and glare to this as well. And I have exported our emission pass here on our meteors layer, which we could use to isolate the fire and add glow just to this aspect of our simulation. However, I do think that our flames in the meteors are going to be bright enough that we can isolate them with a basic glare node. So what I'll do is I'll just press Shift A, I'll add a filter, glare, add this just after our meteor here, and then I'll change the style of glare to fog glow. I'll change the quality to high, and then I'll bring down the threshold to say 0.1. and the size to 9. And now already we're getting a nice little glow around our meteor simulation. I'll go ahead and duplicate this glare node, and I'll bring down the size of this one to 8. And now we have another layer of glare that's just a little bit smaller and more subtle. And you can do this process as many times as you want, obviously, if you want to adjust the glare, but this is the general concept here. I also want to add some glare on top of our sparks. So I'll go ahead and just duplicate one of our glare nodes here, add it right here. I'll bring the size of this one down to maybe 7, just because our sparks are so much smaller. And yeah, already this is looking pretty good. Depending on the background that you're adding your simulation to, you can adjust a few other things. I'll go ahead and, just for the sake of this tutorial, add a background image to our render here. So I'll go ahead and press Shift A. I'll add an input image. Choose an image here from unsplash.com that we used in our visual effects breakdown video. Just this JPEG here, and I'll duplicate our alpha over node and put this in the top input. And we'll wait for the composite. And as you can see here, we have our meteors over top of our background photo. However, our background photo is the wrong size, but no worries, we can fix that with a quick scale node. So I'll press Shift A, add a distort, scale, and change this to render size. And as you can see here, that solved our issue. And right off the bat, I think our meteor is a little bit too bright in comparison to our background photo. So I'll go ahead and press Shift A, add a color RGB curves node right after our glare node for our meteor, and just bring this down a little bit so it's a little bit darker. Let's see what this gives us. Something like this should be pretty good. And now finally, we can just add some color correction on top of our final output here. I'll make the low tones a little cooler, the mid tones a little warmer, and the highlights a little cooler. And then also I'll add another RGB curves node here right after our viewer, just give it a little bit of a boost in contrast. And keep in mind that we didn't originally plan on adding this simulation to this specific background photo. So there are obviously some things we could do differently in order to combine it a little bit more specifically. As far as the simulation goes, it's looking pretty good. I would probably play around with the materials a little bit more, just so we could get a little bit less fiery detail up here, and so it burns off a bit quicker, and try to enhance that smaller scale noise so it matches the detail of our background photo a bit better. But this is the general concept here, guys. I'm going to finish up here just because the tutorial is getting a little bit long already, but this is the general concept. To render this out, of course, all you have to do is go to render and render animation, and Blender will go through all of your different frames and export your final composite here. If you want to actually use all of these compositing steps that we did here, make sure to connect where your viewer node is also to your composite, and you'll have this as your final export. If you'd like, I can make a little bit more in-depth tutorial on compositing this simulation into a live action shot, so leave a comment in the comment section below if you want me to make that video, and I'll be happy to take a look at that as well. But anyways, guys, that is it for this video. I hope it was helpful. As always, feel free to leave a comment if you have any questions or suggestions in the comment section below. Let us know what you'd like to see next on the channel. Subscribe if you're interested, and we'll see you in the next video.